Guys, this is 3.3b. This is the exterior angles theorem. So this diagram right here I think is really helpful. I think it does a really good job explaining what the exterior angles theorem is. So definitely get this in your notes. What it says is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And I think the diagram does a better job than the words there. So you can see what they're talking about with that exterior angle. Basically, it's an angle that kind of shoots off of your triangle. So if you kind of kept extending your triangle and then created a new angle, that angle is going to be equal to whatever it is when you add together those two opposite interior angles. Okay, so let's jump into an example to make sure that that's all making sense. So in these examples, just like in 3.3a, we're going to set up an equation, solve for x, and then use that x to find all of our missing angles. Okay, so the theorem says this. It says that if you extend your triangle and it creates this exterior angle here, that angle is going to be equal to the sum of these two opposite angles. Okay, so the equation looks like this. 5x minus 10 is equal to 3x plus 40. Okay, from there, just an algebra problem. I like to get all of my x's onto the left, so I would probably start by subtracting 3x from both sides, although that's not the only way to do it, but that's one way that'll work. And then we're here. Now that we got all of our variables on the left, let's get our numbers to the right. So let's add 10 to both sides. That'll leave us with 2x equals 50, and then divide by 2. And we're left with x equals 25. Okay, now a couple things that we need to do with that. Number one, we need to take that x and we need to substitute it in right here. So we're doing 3 times 25. So if you have 3/4, you have 75 cents. So that angle is going to end up being 75 degrees. Okay, then we need to take that same x and substitute it in over here. So this time we're doing 5 times 25 minus 10. Well, if you have 5/4, you have $1.25. And if you subtract 10, you're left with $1.15 or 115 degrees. So this angle is 115 degrees. Okay, now one more thing I want us to do. I want us to figure out what this missing angle is right here that I just marked. I'm going to give it 2 marks. Okay, a couple ways to do that. I think the easiest way is using those interior angles. Those interior angles should add to 180. Okay, so if we took 180 and we took away the 40 that we already used up, and we took away the 75 that we used up, we are going to be left with, so that tells us that this angle is 65 degrees. Now, we can even double check our work one more time. What you're going to notice, I'm going to grab a highlighter here. You're going to notice that these exterior angles here create a linear pair. So if you think back to a couple units ago when we talked about linear pairs, they should always add up to 180 degrees. So if we double check 115 plus 65, does that get us to 180? Yes, in fact, it does. So there are lots of ways that you can solve a problem like this. As long as you know about your linear pairs, you know about your interior angles, and you know about your exterior angles, I think you can problem solve your way through that. All right, so one more example here. This one's a little bit different. This time we're supposed to solve for x and y. So I would just start with one of the variables. It doesn't really matter which one you start with, but I'm going to start with x. And in order to solve for x, we need to remember that these 3 angles should add up to 180 degrees. Okay, so you can either use subtraction or you can use addition. It doesn't really matter. I'll maybe do it this way this time. I'm going to say that x plus 42 plus 51 should be equal to 180. Combine some like terms, so add up those numbers. So you're going to have x plus 93 is equal to 180. Subtract 93. And we're left with 87. Okay, so I think x is 87 degrees, so I'm going to fill that in. Okay, now to solve for y, we can do it one of 2 ways. We could use the exterior angle theorem, or we could use the linear pair with the 42 degrees. Either way should get you the same answer. Since we're working with the exterior angles theorem, I'm going to do it that way. So I'm going to say that that outside, whoops, I don't want to be using that. So that outside angle y should be equal to the sum of these opposite two angles. So it should be equal to 87 plus 51. So y is equal to 138. So 138 degrees. And then again, we can check with that linear pair. So we got this guy right here, 138 and 42. That is definitely 180. So that tells us that we did it right. Okay. So in summary, when you're solving for an exterior angle, use the two angles across the triangle, not the ones right next to, but the two that are across the triangle on the inside. If you do that right, these problems shouldn't be too bad for you.